Okay, so ignore all this previous writing. What we are finding in this question is a nuclear reaction that is balanced for an alpha particle decay. First thing that you should know here is that an alpha particle will look like this. Helium with an atomic number 2 and a mass number 4. So I have to find this somewhere in my equation. Also, we're talking about a decay. When it says decay, it means that my particle is going to be on the product side. So let me go and find that. I need to find this particle. I look at it, there's no alpha particle. There's this beta particle. Oops. There's this beta particle, not alpha though. So I'm going to cross out A. B has an alpha particle here, but it is on the reactant side. And because it is a decay, it needs to be on a product side. So it is not B. C, I look at it, there's an alpha particle, it is on the product side, I'm good. D, I look at it, there is an alpha particle, it is on the product side, I'm good. So it is either going to be C or D. So now I have to make sure that it is balanced. I'm going to look at the mass numbers on my reactant side, which is 214, and then the mass number on my product side, which is 210 plus 4, which is 214. So 214 matches with 214, we're good there. So now I'm going to see that the atomic numbers match. So 84 on my reactant side, and then 82 plus 2 is 84. So 84 matches with 84. We're good there. Let me move on to D just to make sure that I'm not like overseeing something. So 214 on my reactant side, 218 plus 4 is 222. 222 does not equal 214. So therefore this equation is not balanced, so it cannot be D. Therefore my answer is C. Next, write the balanced equation for the following reaction. So for these, you want to go in and fill out the element symbols that you do know, and then you want to make sure that you are doing the physical, the state of matter. Sorry guys. You're doing the state of matter for each one, and then you have to balance everything out. So solid, suggesting that I should have an S between parentheses. Magnesium, Mg, reacts with, that means that I'm going to have some kind of plus sign. Oxygen gas. Oxygen gas is a diatomic molecule. Therefore, when you are writing it, it has to be O2. And it is a gas. To produce solid, so again a parenthesis with an S in it, and then they gave you the product, MgO. So let me write this equation properly. I'm going to write magnesium, and it's solid magnesium. The state of matter goes after the element symbol, plus oxygen to gas makes MgO, and that is solid. So now I have my basic equation, but I have to go in and balance it. So I have magnesium and oxygen on this side. I have magnesium and oxygen on this side. So I am going to go in and count how many atoms I have. So I have 1 magnesium atom on this side. I have 2 oxygen atoms. I have 1 magnesium on this side, and I have 1 oxygen atom on that side, or on the product side. So now I see that magnesiums match up. They both have 1, but oxygens are not equal. So I have to make them equal. I'm going to try to multiply this one by 2, meaning I have to put a 2 coefficient in front of where my oxygen is, which is right here. That makes my oxygen now equal to 2. That matches. But now I also multiply this 2 coefficient to my magnesium. So magnesium is also multiplied by 2. And now I'm like, oh man, my magnesiums don't match up. So now I have to go to this side and be like, well, what do I do to make 2 match with 1? I can multiply 1 by 2, and that means that I have to put a 2 coefficient in front of my magnesium. And then I check. I have 2 magnesiums on my reactant side. I have 2 magnesiums on my product side. I have 2 oxygens on my reactant side. I have 2 oxygens on my product side. And now I'm finally balanced. So this is my equation, balanced with the states of matter and with the proper coefficients. Next one. What type of reaction is demonstrated on number 2? So I have magnesium, I have oxygen, and I combine them to form one compound. This combination, when you take one thing and you take another thing and you bond them together to form a compound, that is called a synthesis reaction. Synthesis means to make. You are creating something, specifically a compound, putting together things, bonding them to make one thing. That is a synthesis reaction. Next one. Write the balanced equation for the following reaction. Again, we are writing equations here. Potassium, I know that symbol is K, reacts with water. You have to memorize that. That is H2O. To produce, that means an arrow. Hydrogen gas. This is a diatomic molecule. So you have to remember to put a little 2 subscript next to hydrogen. And KOH. So I have potassium reacts with water, K plus H2O, to produce arrow, hydrogen gas, a diatomic molecule, plus KOH. So now I have to make sure that this is balanced. So I have potassium, hydrogen, and oxygen on my reactant side, and I have potassium, hydrogen, and oxygen on my product side. So I have 1 potassium atom, 2 hydrogen atoms, 1 oxygen atom. I have 1 potassium atom, 3 hydrogen atoms, and 1 oxygen atom. So now I have to go in and try to balance things out. Potassiums match, hydrogens do not, and oxygens match. So let's start trying to balance out hydrogen. So I'm going to go here because this is the odd man out because there's only 1 oxygen here. And I'm going to say, I'm going to multiply you by 2. So I'm going to put, let me get a different color here. I'm going to put a 2 coefficient here. That means that now I have 2 potassium, I have 2 oxygen, and I have 2 hydrogens, but I also have 2 hydrogens here, so I have a total of 4. Okay, so now let me go to this side. If I have 2 potassiums on this side, I can multiply this one by 2. That means I have to put this 2 coefficient in front of my potassium to make it equal. And now I have 4 hydrogens, but I have 2 here, so I can put a 2 in front of my hydrogens to multiply to equal to 4. Because I did that, I also multiplied my oxygen by 2 to equal a total of 2. So now I have 2 oxygen atoms on both sides, 2 hydrogen atoms on both sides, and 2 potassium atoms on both sides, and this is my balanced equation. And then last one for this video, pick the precipitation reaction. Anytime I see precipitation reaction, let me move that a little bit, there it is. Anytime I see precipitation reaction, I should think, ooh, I start with aqueous or liquids and with a solid. So I start with aqueous and liquids, only these 2, and I have to end with a solid. So I'm going to go into each of my reactions and find which ones start with aqueous or liquid solutions in my reactants and end with a solid product. I see this one, and this one starts with a solid, so I can automatically say that is wrong because I have to start with aqueous or liquids, so it is not A. B. Aqueous, okay, that checks off, starting with aqueous or liquids, ends with a solid. That checks off. I have only aqueous or liquids, and I have a solid at the end. Maybe that's B. Maybe that's the answer. Let's see this one. Solid. I start with a solid here. I cannot do that for a precipitation reaction because I can only start with aqueous or liquids, so it is not C. Last one, I also have a solid here. I should not be starting off with solids for a precipitation reaction, only aqueous or liquids, so it is not D. Therefore, my answer is B.